Good morning students. Today we have lecture number 8. Lecture number 8 on electromagnetic induction for second year. Okay. So in the lecture number 7 we have studied the theory of up to lecture number 7 we have studied the theory of entire electromagnetic induction. So how much it is required for the theory exam, that much we have studied. And then we have solved some numericals. Let us solve some more numericals on the electromagnetic induction. Write down the next question. Write down the next question. We will solve here only. Okay. Write down the next question. A flat coil of 500 tons. A flat coil of 500 tons. A flat coil of 500 tons, comma, each of area 5 into 10 to the power minus 3 meter square. A flat coil of 500 tons, comma, each of area 5 into 10 to the power minus 3 meter square, comma, rotates in a uniform magnetic field of 0.14 Tesla. Rotates in a uniform magnetic field of 0.14 Tesla at an angular speed of 150 radian per second. At an angular speed of 150 radian per second. At an angular speed of 150 radian per second. You please stop. Once again I will repeat the sentence. A flat coil of 500 tons. A flat coil of 500 tons, comma, each of area 5 into 10 to the power minus 3 meter square, rotates in a uniform magnetic field of 0.14 Tesla at an angular speed of 150 radian per second. You please stop. The coil has a resistance of 5 ohm. 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 You please stop. The induced EMF is applied to an external resistance of 10 ohm. The induced EMF is applied to an external resistance. The induced EMF is applied to an external resistance of 10 ohm. External resistance of 10 ohm. So this as R and this as R2. Okay. The induced EMF is applied to an external resistance of 10 ohm. You please stop. Calculate the peak current through the resistance. Calculate the peak current through the resistance. Calculate the peak current through the resistance. Okay, this is the question. Read the question properly. First read the question and try to understand the given data and all the things, then you try to solve it. It's very simple questions. Okay, see here what is given. A flat coil of 500 tons, that is number of tons is 500. Okay, each of area 5 into 10 to the power minus 3 meter square, that is area of each coil, area of each flat coil is 5 into 10 to the power minus 3 meter square. Rotates in a uniform magnetic field of 0.14 Tesla. The magnetic field is uniform and the coil is rotating at an angular speed of 150 radian per second. Okay. The coil has a resistance. The resistance of the coil is 5 ohm and this coil is connected to an external resistance of 10 ohm. The coil resistance of the coil is 5 ohm and the external resistance, that is the coil is connected to an external resistance 10 ohm. Then find out the peak current through the resistance. Find out the peak current through the resistance. That is peak current through the external resistance. Okay, see here. This is EMF induced, that is due to the change in orientation, rotation, due to the change in orientation between the magnetic field and the coil, between the magnetic field and coil. So therefore, the induced EMF, not induced EMF, we want peak current. Peak current, what do you mean by peak current? Peak current means maximum current. Peak current means maximum current. So let us find directly the maximum EMF. The maximum EMF induced or peak EMF induced, the peak EMF induced is given by it is E naught is equal to NBA omega. This is the formula for maximum EMF induced in a coil due to the change in orientation. We have studied this in theory of AC generator. And now first to find out this E naught, and then resistance, total resistance we have to take. Resistance of the coil plus external resistance, then total resistance. Okay, I will write here only. Okay, we will calculate this one and then we shall write that one. So E naught is equal to N is 500 into magnetic field is 0.14 and area of each coil is 5 into 10 to the power minus 3 and angular velocity is 150 radian per second. And now do the calculation, and after calculation you will get the answer for this one as I will write directly answer. So you do the calculation on your own. So E naught will come out to be 52.5 volt. E naught will come out to be 52.5 volt. So now this is the maximum EMF induced, and now the total resistance is R is equal to, so that is 5 plus 10, it is R is equal to 15 ohm. So therefore peak current or maximum current, peak is nothing but maximum current, that is I naught, we have written it as I naught is equal to E naught divided by R. So therefore I naught is equal to E naught, that is 52.5 divided by capital R, that is total resistance is 15. So calculate this one, you will get the answer. So I naught will come out to be, the value for this I naught will come out to be 3.5 ampere. Okay. So this is the answer. Understood? Okay. So see, the question is simple. Only thing is you have to remember to find these formulas and how to apply and how to calculate. Okay. Okay, right, done. Next question is homework. Homework for you people, you have to do at the home. Right, done. A circular coil of area 300 centimeter square. A circular coil of area 300 centimeter square. A circular coil of area 300 centimeter square, comma, and 25 tons rotates about its vertical diameter with an angular speed of 40 per second. A circular coil of area 300 square centimeter, comma, and 25 tons rotates about its vertical diameter with an angular speed of 40 per second in a uniform magnetic field of 0.05 Tesla. In a uniform magnetic field of 0.05 Tesla. You please stop. In a uniform magnetic field of 0.05 Tesla. You please stop. Obtain the maximum voltage induced in the coil. Very simple question. Obtain the maximum voltage induced in the coil. So the answer will come out to be, I will give the answer. Directly I will give the answer. You only have to do at the home. Answer will come out to be 1.5 volt. Answer for this one is 1.5 volt. That is homework. You have to do at the home. Okay. Next question. Write down the next question. Next question. A 200 turn coil. A 200 turn coil of self inductance. A 200 turn coil. Next question, here only we will do. A 200 turn coil of self inductance 20 millihenry. A 200 turn coil of self inductance 20 millihenry carries a current of 4 milliampere. Carries a current of 4 milliampere. A 200 turn coil of self inductance 20 millihenry carries a current of 4 milliampere. 4 milliampere. Cube list of find the magnetic flux. Find the magnetic flux linked. Find the magnetic flux linked with each turn of the coil. Find the magnetic flux linked with each turn of the coil. Find the magnetic flux linked with each turn of the coil. Find the magnetic flux linked with each turn of the coil. Find the magnetic flux linked with each turn of the coil. Okay. See here, how to solve this one? So, simple question. Let phi be the magnetic flux linked with each turn of the coil. Each turn of the coil. Then we can write N phi is directly proportional to I. It is the total magnetic flux. The total magnetic flux in the coil will be directly proportional to the total current flowing through the coil. That is, we already know the magnetic flux is directly proportional to the current, not induced current. This is the current flowing through the coil. Okay. So now that you can write it as, so it is N phi is equal to, that is proportionality sign, remove the proportionality sign, then you have to put a constant and that constant is L into I, where L is called self inductance of the coil, where L is self inductance of the coil. L is self inductance of coil. So therefore, so you can write phi is equal to Li divided by N. Phi is equal to Li divided by N. That is magnetic flux linked with each turn we want. So it is phi we want. So therefore phi is equal to Li divided by N. Okay. So therefore, so phi is equal to L. L is 220 millihenry. That is 20 into 10 to the power minus 3. I is 4 milliampere. 4 into 10 to the power minus 3 divided by N. N is 200. So do the simplification. So you'll get the answer. So answer will come so to be, okay, answer will come so to be 4 into 10 to the power minus 7 Weber. 4 into 10 to the power minus 7 Weber. So this is the answer. See here, how to write this formula. In the theory classroom, we have written that total magnetic flux linked with a coil is directly proportional to the current flowing through the coil. Understood? So that's what the total magnetic flux means N phi, because phi is the magnetic flux linked with each turn of the coil. Phi is the magnetic flux linked with each turn of the coil. Then N phi will be the total magnetic flux, and that total magnetic flux is directly proportional to the current flowing through the coil. So you will get phi. So remember this formula. So if they give the value of phi Li and they ask you to calculate N, then you can write the formula N is equal to Li divided by phi and do the calculation, you will get N. Understood? So okay. Next question. Homework. A coil has an inductance of, homework this is. A coil has an inductance of 5 millihenry. A coil has an inductance of 5 millihenry. A coil has an inductance of 5 millihenry, A coil has an inductance of 5 millihenry, In it, current changes from in it current changes from 0.1 ampere to 4.1 ampere. In it current changes from 0.1 ampere to 4.1 ampere in 0.5 second. In 0.5 second. In 0.5 second. Give please stop. A coil has an inductance of 5 millihenry. In it current changes from 0.1 ampere to 4.1 ampere in 0.5 second. Give please stop. Calculate the induced EMF. Calculate the induced EMF. So, what is the value of induced EMF? Do on your own. And such kind of questions have been asked in the theory question paper for 2 marks and 3 marks. Many times, 2 to 3 times they have asked such kind of questions. They have asked in the theory question paper. Old theory question papers. So, they have asked such kind of questions. Try to solve this one, each and every one. Understood? So, for 2 marks or 3 marks, such kind of questions will come. Okay. So, I can also solve, but if I solve each and every problem, so you will not learn anything. See here, I will give the homework so that you have to learn. Not because I cannot solve or not because it will take longer time. So, it's only the point is that you will learn more. One, when you will solve the numericals on your own. See here, in the physics, numericals are the difficult part. Generally students will tell numericals are the difficult part, because the reason that they will tell it as difficult part because they don't try to solve the numericals on their own. If they try to solve the numericals on their own, then numericals will not be difficult in the exams or whatever it may be. Understood? So, try to solve the numericals on your own. That's why I am giving the homework. Okay. Next question. Write down the next question. Okay. Next question, homework. If a rate of change of current of 4 ampere per second, if a rate of change of current of 4 ampere per second, induces an EMF of 20 millivolt. If a rate of change of current of 4 ampere per second induces an EMF of 20 millivolt. In a solenoid. Okay, I will solve this one here only we will solve, not homework. This one here only we will solve. If a rate of change of current of 4 ampere per second, induces an EMF of 20 millivolt in a solenoid. This is solenoid, related to solenoid. Come on. What is the self-inductance of the solenoid? See the question. So, what they have given? If a rate of change of current of 4 ampere per second, rate of change of current, that is nothing but di by dt. Di by dt is nothing but rate of change of current, that is 4 ampere per second, and induces an EMF of 20 millivolt. Induced EMF is 20 millivolt in a solenoid. What is the self-inductance of the solenoid? That is the question mark. Okay. So, we have already studied the formula for self-inductance of a solenoid, air-cored solenoid. Understood? So, if you use that formula, you won't get the answer. That formula if you use, you won't get the answer. See here, that formula was like this: L is equal to mu naught n square into LA. That is the self-inductance. Okay. So, not required. Okay. So, if you use that formula, you won't get the answer. So, you have to use the induced EMFs here. According to the given data, you have to use the question. You have to use the formula. Formula must be used. What is the given data? According to the given data, you have to use the formula. the induced EMF is given by, the induced EMF is given by E is equal to minus L di by dt. E is equal to minus L di by dt. You know this formula. Actually, E is equal to d phi by dt minus d phi by dt according to Faraday's law. And thus, phi is equal to L into I. Phi is equal to L into I. So, therefore, E is equal to minus L di by dt. You have derived all these formulas in the theory classes, and L is self-inductance of the coil and di by dt is rate of change of current and E is induced EMF. So, therefore, L is equal to, so E divided by di by dt. Only we want L value, so you can write it as, neglect the negative sign. So, L is equal to E divided by di by dt. So, L is equal to, so I am substituting the values. So, L is equal to, what will get? L is equal to, that is 4 ampere per second divided by di by dt. Di by dt is 4. So, E value is 20 millivolt, that is 20 into 10 to the power minus 3, and di by dt is 4. So, you will get L is equal to 20 divided by 4, that is 5. So, 5 into 10 to the power minus 3 volt is 10 to the power minus 3 Henry. L is equal to 5 into 10 to the power minus 3 Henry. This is the self-inductance of the coil. Okay. Solenoid. Okay. Next question. We will solve here only. Here only. Next question. Right. An air-cored solenoid with length 30 centimeter. An air-cored solenoid with length 30 centimeter. An air-cored solenoid with length 30 centimeter. Area of cross section 25 square centimeter. Area of cross section 25 square centimeter square. An air-cored solenoid with length 30 centimeter, comma, area of cross section 25 centimeter square. And a number of turns 500, comma, carries a current of 2.5 ampere. Carries a current of 2.5 ampere. Current in that coil is 2.5 ampere. Okay. You please stop. Once again I will read the question. Once again I will read the sentence. An air-cored solenoid with length 30 centimeter, area of cross section 25 square centimeter, and a number of turns 500, carries a current of 2.5 ampere. You please stop. The current is suddenly switched off. The current is suddenly switched off in a brief time of 10 to the power minus 3 seconds. The current is suddenly switched off in a brief time of 10 to the power minus 3 seconds. That is, current is decreased to 0. Current is reduced to 0 in a brief time of 10 to the power minus 3 seconds. That is, you can write it as dt, and final current is 0. Final. This is initial current, and final current is 0 ampere. Okay. The current is suddenly switched off in a brief time of 10 to the power minus 3 seconds. You please stop. How much is the average back EMF induced? How much is the average back EMF induced across the ends? How much is the average back EMF induced across the ends of the open switch? How much is the average back EMF induced across the ends of the open switch in the circuit? Question mark. How much is the average back EMF induced across the ends of the open switch in the circuit? How much is the average back EMF induced across the ends of the open switch in the circuit? Question mark. Okay. So if you want, you can draw the diagram. So a air-cored solenoid. A air-cored solenoid means, so this is a solenoid. Okay. Length 30 centimeter, area of cross section. Length is L and area of cross section is A. And number of turns is N. Number of turns is N. Carries a current of 2.5 ampere. Carries a current of 2.5 ampere. Okay. Okay. Then what else? The current is suddenly switched off in a brief time of 10 to the power minus 3 seconds. How much? Okay. Let us say there is a current means there is a EMF. Battery is there and there is a switch. There is a switch. This is plug key or switch, or you can call this as a switch. Okay. So the current is suddenly switched off in a brief time of 10 to the power minus 3 seconds. In 10 to the power minus 3 seconds, the current is suddenly switched off. That is, the current is suddenly switched off by unplugging the plug key. That is by switching off the plug key. Unplug the plug key. That is open. Open condition. Open means switching off. Closed means on. Okay. Open. That is, how much is the average back EMF induced across the ends of the open switch in the circuit. So what is the back EMF induced? What is the back EMF induced across the ends of the open switch? Understood the question? What is the back EMF? Back EMF is nothing but induced EMF. The induced EMF induced across the ends of the open switch. That is nothing but the EMF induced in the coil. The EMF induced in the coil will be the EMF induced across the open switch. The EMF induced across the open switch will be same because these wires are considered to be resistance-less. Okay. Okay. So now how to find this one? So what are the given things? Given things is we have written. So write them in SI unit. So length of the coil is 30 centimeter. That is in meter. If you write 0.3 meter. 30 centimeter, 0.3 meter, 30 into 10 to the power minus 2. So 25 square centimeter, that is 25 into 10 to the power minus 4 meter square. 25 into 10 to the power minus 4 meter square, 500 tons. And current changes from where to where? 25 ampere to 0 ampere. That is final current is 0 ampere, initially is 25. So in a time period. So now rate of change of current. Rate of change of current is, that is di by dt. Di by dt. How to calculate? Final current minus initial current. Di is nothing but change in current. Change in current is final is 0 minus initial is 2.5 divided by time taken is 10 to the power minus 3. So 2.5 minus 2.5 divided by 10 to the power minus 3. So this is the value of di by dt. Okay. Okay. Then what we want? What we have to calculate? So average back EMF, that is induced EMF. The average induced EMF, the induced EMF is given by, the induced EMF is given by, I will write directly, is given by E is equal to minus L di by dt. E is equal to minus L di by dt, where L is self-inductance, where L is self-inductance, self-inductance of solenoid. This is a solenoid. See the question properly, it is a solenoid or a coil? A air-cored solenoid. He has mentioned in the beginning only, air-cored solenoid. So L is the self-inductance of solenoid. So we know that. Self-inductance of the solenoid is given by. So according to the given data, whatever the given data, in that terms you have to write. So given data is number of turns, not per unit length, number of turns, total number of turns is given. So therefore you can write the formula like this: mu naught n square into A divided by L. Mu naught n square into A divided by L. So that is the formula for self-inductance of a solenoid. Self-inductance of a solenoid. Understood? Okay. So now substitute this. Call this equation number 2. Call this equation number 1. Substitute equation 2 in 1. So therefore E is equal to minus L. L is mu naught n square A divided by L into di by dt. So now substitute the values and you will get the answer. So minus, what is the value of mu naught? You have to remember the constant values. See here in the exam they will not give the values of constant. So whatever the constants you will have in all the chapters, in physics you will get constant values in almost all the chapters. We have to remember the value of mu naught is 4 pi into 10 to the power minus 7 into n square. N square is 500 square, and area is 25 into 10 to the power minus 4 divided by L. L is 0.3, and di by dt is minus 2.5 divided by minus 2.5 divided by 10 to the power minus 3, that is minus 2.5 into 10 to the power plus 3 you can write. So minus into minus it becomes plus, and simplify this one. This is multiplication multiplied by minus 2.5 divided by 10 to the power minus 3. So simplify that, you will get the answer. I will tell the answer directly. Calculation is left to you people, you have to do the calculation. Minus into minus it becomes plus, so you will get 6.542 volt. 6.542 volt. This is for a theory exam. Okay. In the theory exam, small calculator is allowed. So you will get such kind of calculation for the theory exam. Okay. So do the calculation and you will get the answer. Check out the calculation once, whether the answers are correct or not. Okay, next question. Write down the next question. Next question you write. A conductor of length 3 meter. A conductor of length 3 meter. Next question. A conductor of length 3 meter. A conductor of length 3 meter. His length is given L is equal to 3 meter. April 2018. A conductor of length 3 meter moving in a uniform magnetic field of strength. 100 Tesla. Moving in a uniform magnetic field of strength 100 Tesla. Pupil stop. A conductor of length 3 meter moving in a uniform magnetic field of strength 100 Tesla. Pupil stop. It covers a distance of 70 meter. It covers a distance of 70 meter in 5 seconds. In 5 seconds. It covers a distance of 70 meter in 5 seconds. Give full stop. Its plane of motion makes an angle of 30 degree. Its plane of motion makes an angle of 30 degree with the direction of magnetic field. Its plane of motion makes an angle of 30 degree with the direction of magnetic field. Its plane of motion makes an angle of 30 degree with the direction of magnetic field. Its plane of motion makes an angle of 30 degree with the direction of magnetic field. You please stop. Calculate the EMF induced in it. Calculate the EMF induced in it. Calculate the EMF induced in it. See the question, read the question properly. This is for 5 marks. A very simple question, and it is for 5 marks. Just 2 steps of answer, you will get 5 marks. Okay, see what the question is given. The length of the coil, a conductor of length 3 meter. Length of the coil is given and moving in a uniform magnetic field of strength 100 Tesla. Moving, that is motional EMF. See the question and try to identify which formula you have to use. Moving in a uniform magnetic field, that is motional EMF you have to use. So moving in a uniform magnetic field of strength 100 Tesla. Okay. It covers a distance. So distance covered is 70 meter in time 5 seconds. He has given. Its plane of motion makes an angle of 30 degree with the direction of magnetic field. So its plane of motion makes an angle of 30 degree with the direction of magnetic field. Then find out the induced EMF. First find out velocity. Velocity of the conductor. Velocity of conductor is given by velocity of conductor V is equal to distance covered divided by time taken. That's we know already. Distance covered divided by time taken, and distance covered is 70 and time taken is 5. So 70 meter and time taken is second. So meter per second. So V is equal to how much you will get? So it is 14 meter per second. 14 correct? 14 meter per second. So that is velocity of the conductor. So now the motional EMF induced, the motional EMF induced in the conductor is given by E is equal to BLV. While deriving, we have derived only this much. E is equal to BLV, we have derived like this. Understood? And during the derivation, we have told that the velocity of the conductor is perpendicular to the magnetic field. The velocity of the conductor is perpendicular to the magnetic field. If you want, you can once again go through that video. In that we have, while deriving this equation, that is motional EMF, we have derived only E is equal to BLV. And we have explained that the velocity of the conductor is perpendicular to the magnetic field. And now the plane of the coil, that is, makes an angle of 30 degree with the magnetic field. So therefore now the formula we have to write is E is equal to BLV into sin theta. When the velocity makes an angle theta with the magnetic field, that is when the plane of the coil makes an angle theta with the magnetic field, then induced EMF is given by E is equal to BLV sin theta. This is just a small adjustment we have to make. Okay, then you will get the formula E is equal to, now substitute the value B, magnetic field B is 100, length is 3 meter, and velocity is 14 into sine of 30 degree. Now simplify this one and you will get the answer. On simplification. So do the simplification, you will get the answer as 2100 volt. 2100 volt. Understood? So this is the question asked in the theory question paper of April 2019. For how many marks? 5 marks. For 5 marks they have asked this much. Understood? Try to solve the question properly and try to understand the concept properly. Okay, next question. Write on the next question. Next question. Question number you only know. Okay. A circular coil of radius 10 centimeter. 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 And 25 tons. Is rotated about its vertical diameter. A circular coil of radius 10 centimeter and 25 tons is rotated about its vertical diameter. With an angular speed of 40 radian per second. A circular coil of radius 10 centimeter and 25 tons is rotated about its vertical diameter with an angular speed of 40 radian per second, in a uniform horizontal magnetic field. Of magnitude in a uniform horizontal magnetic field of magnitude 5 into 10 to the power minus 2 Tesla. In a uniform magnetic field, in a uniform horizontal magnetic field of magnitude 5 into 10 to the power minus 2 Tesla. Once give full stop. Once again I will read the sentence from the beginning. A circular coil of radius 10 centimeter and 25 tons is rotated about its vertical diameter with an angular speed of 40 radian per second, comma, in a uniform horizontal magnetic field of magnitude 5 into 10 to the power minus 2 Tesla. Give full stop. Calculate the EMF induced in the coil. Calculate the EMF induced in the coil. Put a star mark on this sentence. See here, I am writing the sentence also. Here I will write this sentence only. Calculate the EMF induced in the coil. Calculate the EMF induced in the coil. This is given in the question paper. Okay. Calculate the EMF induced in the coil. Give full stop. Calculate the EMF induced in the coil. Give full stop. Put a star mark for this question, this sentence. Calculate the EMF induced in the coil. Give full star mark. Give full stop. Also find the current in the coil. Also find the current in the coil if the resistance of the coil is 15 ohm. Also find the current in the coil if the resistance of the coil is 15 ohm. Also find the current in the coil if the resistance of the coil is 15 ohm. Okay. Also find the current in the coil if the resistance of the coil is 15 ohm. You please stop. Okay, this was asked in March 2018. Okay, I will tell you one work. Pause the video and try to solve this question on your own first. Pause the video and try to solve on your own, and if you did not get the answer, I will be solving now only. Pause the video and try on your own. If you did not get, watch the video. Okay, so now I hope that you have paused the video and tried to solve on your own. Okay, see here. So there was a mistake in this question paper. In this question, this sentence is wrong. So they have asked calculate the EMF induced in the coil. So here they did not mention which EMF we have to induce, which EMF we have to calculate. We have to calculate maximum EMF or induced EMF. Which EMF we have to calculate? It is not given properly. Actually, according to the question, so this is rotation of the rod, right? A circular coil of radius 10 centimeter and 25 tons is rotated about its vertical diameter with an angular speed of, that is given in a uniform horizontal magnetic field of magnitude. Okay. Calculate the maximum EMF induced in the coil. Okay. Calculate the EMF induced in the coil. Actually, this has to be maximum EMF induced. It has to be maximum EMF induced in the coil. The question has to be like this. Calculate the maximum EMF induced in the coil. Then it will becomes correct. So, for this question, when all attempted, for that year, I have gone to the valuation at Bangalore Valuation Center. So, there during the valuation, if the students solve it for maximum current, maximum EMF, then also the marks is given. If the student tried to solve and did not got the answer, then also the marks was given. Because there was a mistake and it was considered as grace marks. Okay. Okay. So such kind of small mistake is there. So we rectify the mistake by introducing the word maximum EMF induced in the coil. Okay. So if you substitute the value of maximum, then the question becomes correct. Okay. Now we will solve the question. The maximum EMF induced in the coil. The maximum EMF induced is given by E naught is equal to NBA omega. NBA omega. This is the maximum EMF induced in the coil. So that's so substitute the values. So it is E naught is equal to N. N value is 25. B, magnetic field B is 5 into 10 to the power minus 2 Tesla. And A, area of the coil. Area of the coil you have to calculate pi r square. You have to calculate pi r square into omega. Omega is given as 40 radian per second. So E naught is equal to 25 into 5 into 10 to the power minus 2 pi r square is 0.1 whole square into 40. So simplify this one and you will get the answer as E naught is equal to, so that is you will get 5 pi into 10 to the power minus 1 volt. So whatever the value you will get, I just kept it in 5 pi. So you do the calculation and you only tell the answer how much you will get. Okay, and then current, and then current, the maximum current only. So current I naught is equal to E naught divided by R. E naught is, so whatever the answer you get, substitute that answer, divided by resistance is given 15. So that is 5 pi into 10 to the power minus 1 divided by 15, and solve this one and you will get the answer. So that is how you have to solve this question. Actually it was a wrong question, mistake question. So mistake is only that they have to mention it as maximum, then it becomes a correct question. Okay, and try to solve. This is asked in March 2018. Okay. Okay. Next question. Next question. Next question. A pair of adjacent coils. A pair of adjacent coils. A pair of adjacent coils has a mutual inductance of. A pair of adjacent coils has a mutual inductance of 1.5 Henry. A pair of adjacent coils has a mutual inductance of 1.5 Henry. You please stop. A pair of adjacent coils has a mutual inductance of 1.5 Henry. You please stop. If the current in one coil changes from, if the current in one coil changes from 0 to 20 ampere. If the current in one coil changes from 0 to 20 ampere in 0.5 second, in 0.5 second, in 0.5 second, you please stop, you comma, not full stop, comma. What is the change of flux linkage with the other coil? What is the change of flux? What is the change of flux linkage with the other coil? What is the change of flux linkage with the other coil? What is the change of flux linkage with the other coil? Okay. Here, read the question properly, you will get the answer very easily. What is the change of flux linkage with the other coil? Okay, what they have given? Once again I will read the question. A pair of adjacent coils has a mutual inductance of 1.5 Henry. So mutual inductance for a pair of coil, that is we have written like this, M12 is equal to M21, that is mutual inductance of the second coil with respect to first coil, and that will be equal to mutual inductance of the first coil with respect to second coil, that is in general is equal to M. Both are same. Okay, and they have given it as 1.5 Henry. If the current in one coil changes from 0 to 20 ampere, current in one coil changes from 0 to 20 ampere, that is change in current, change in current, it is di, final minus initial, 20 minus 0. So from 0 to 20, so 20 minus 0, so you will get 20 ampere. So di by dt, rate of change of current, that is 20 divided by 0.5. 20 divided by 0.5, and 0.5 is nothing but 1 by 2, so you can write it as 40 ampere per second, di by dt as 40 ampere per second. Okay. So now what they are asking is, what is the change of flux linked with other coil? What is the change of flux linked with other coil? That is, the question is d phi is equal to question mark. D phi is equal to question mark. Understood? Okay, let us see. So we know that the flux linked, that is the induced EMF, is given by the induced EMF in a mutual inductance is given by E is equal to minus M di by dt, minus M di by dt. Induced EMF, you will get E is equal to d phi by dt, right? E is equal to minus d phi by dt. So M di by dt, there you can write, because phi is equal to M into I, like phi is equal to L into I. So we have already studied all these things. So now they want, what they want is the change in flux. They want change in flux, and since we can also write E is equal to d phi by dt, okay, minus d phi by dt. E is equal to minus d phi by dt, and now combining these two formula, what you will get, minus d phi by dt is equal to minus M di by dt, right? And now dt get cancel. So therefore d phi is equal to M into di. D phi is nothing but change in flux. D phi is nothing but change in flux, and that's what we want. We want change in flux. So therefore d phi is equal to M. M is given as 1.5, and di, only di we want di by dt. Di by dt is not required, only we want di. So di is change in current is 20. So 20 into 1.5, that will become 30. Okay, so 30 Weber. So 30 Weber. So that is the answer. 30 Weber, that is the answer. So see how we have solved this question. See how we have made the formulas. E is equal to minus M di by dt, and that formula we have obtained like this. So now resubstitute E is equal to minus d phi by dt here. So minus d phi by dt, minus M, minus cancel. So d phi is equal to M di. So d phi is equal to, you will get the answer like this. Understood? Okay. So these all are some numericals which we have to learn in this chapter, and some more numericals we will solve if possible. So otherwise we will shift to the next concept.